Yeah.
Right.
Oh, excuse me.
Chris, we can see you.
No, what's gonna happen? Jim just emailed.
I feel a little uncomfortable because I wouldn't view myself as like a soil health person. So you're gonna take it all with a grain of salt.
Cool. Sorry? Yeah, maybe we could just turn this one on. Sure. Yeah. Okay. Does this layout work for people?
Nothing's beyond.
Yes. Awesome. Cool. Thanks. So this is Chris Benedict, who, do you want to introduce yourself briefly, Chris?
Sure. Chris Benedict, I work for WSU Extension, but I'm also kind of responsible for pushing the lead on the soil health initiative that just sort of started a couple months ago. So.
Yeah, so I have been chatting with Chris after the faculty retreat of Crop and Soils, and we thought that it would be cool to start having a roughly monthly kind of conversation, bringing together people within WSU, people outside WSU, to talk about soil health. And so Rich Koenig is joining us, and so he agreed to give us a little update on the soil health initiative.
All right.
We're interested.
Thanks, Maren.
Mhm.
I'm not sure what camera I should be looking at. I think
You're not on it
one
anyway.
of those. I'm not on it.
No.
Let me walk around here.
You have to be up front where they're at.
Just a brief update on the soil health initiative, and welcome, Linda.
Yes.
Yeah, Rich Koenig, Chair of Crop and Soil Sciences. Looking forward to your seminar. Thanks for also agreeing to this facilitated session before the seminar. So a brief update. I think most of you know that we did get part of the funding for the state soil health initiative, but it's a temporary allocation of $250,000 each year for this biennium. So we have $250,000 a year for each of the next 2 years, with a promise, or I wouldn't make, well, Chris, maybe a promise is too strong a word to use, but an indication that we could go back and request the full amount, which is $1 million a year of ongoing funding, and then about $750,000 in one-time equipment funding. So from the state anyway, we think we have very good prospects, very good likelihood of getting the full funding, hopefully in this upcoming legislative session. So that's the good news. There's the prospect of significant investment from the state. There's also a lot of momentum on the part of ag industry, the commodity groups, and funding soil health. The tree fruit industry has the endowed chair in soil and rhizosphere science. Many of the things that they talk about for that chair are soil health related. The potato industry is about $2.8 million of $3 million of funding in hand for a distinguished endowed chair in soil health for irrigated cropping systems that emphasize potatoes in rotation. The small grains industry has been interested in soil quality, soil health for many years. They may come around. Grapes, wine, also very interested. So a lot of good interest in soil health. Money that's flowing in this area or to this area. So yeah, I think good reason to be optimistic. Now we just have to deliver on what is soil health, how can we measure it, map it, and then how can we deliver to industry what they call actionable things that they can do to improve soil health and see the benefits. Okay.
Yeah, great. Thanks, Rich. All right. Okay, so Chris and I have prepared a list of kind of starter questions that I'm going to pose to Linda and Bill. But feel free to raise your hand if you have something you want them to expand on. And then if we get through these, we'll just open it up to the audience. Yeah, so I'm hoping that this will be kind of more of a discussion conversation than a strict like Q&A kind of thing. So let's start with a softball question. What is your personal definition of soil health? And let's start with Bill.
Do you want?
Oh, I defer.
Okay. Well, I had to just look this up because I wanted to make sure I was on solid ground. But, if you go to the NRCS definition, it's the ability of soil to function however you want it to function, and functionality would vary. Rich rattled off a bunch of commodity commissions that were interested in soil health, obviously to produce better yields and better quality of whatever crop they're interested in. So that's one function. But it could be about decontaminating toxic chemicals. It could be purifying water, a whole host of different functions that you want it to do. I personally like, and so NRCS almost equated the term soil health to soil quality and almost made it synonymous. But I think one of the distinctions that I'm seeing coming forward is there's a real emphasis now on how do you test the characteristics that would allow that soil to function however you want it to function. So a lot of emphasis on the metrics of soil quality, and that's why I kind of prefer to emphasize, the metrics or the characteristics of a soil that allows it to function as the definition of soil health.
Okay, how are you, Linda?
I like a lot what Bill said. Soil health is something that I've avoided using in almost any of my grants or research because it's been frustrating. From where I sit, there isn't a clear, objective, quantifiable set of criteria that says this is a healthy soil. This is what makes a healthy soil. And soil science has traditionally focused on soil, and I'm a microbiologist, and for us, we realize so much of what makes a healthy plant or an unhealthy, unproductive plant has to do with that microbial life, which traditionally in much of soil metrics has been invisible. And so I've always been a little troubled by soil health because it seems vague, but I do agree that the metrics that having these discussions between soil scientists, pathologists, microbial ecologists, really coming to grips with what are these different things that we measure, which ones are important, where and when. I think that's a discussion that needs to occur. And there is money. Growers want to know this stuff. Not just growers, but carbon sequestration is becoming really important as a functional characteristic of soils. We need to start stepping in with the science, the microbiome science or the soil science, to get those correlative metrics that will help us drive a discussion forward, recognizing that most of what we're doing right now is only correlative. It's not really mechanistically driven, but you have to start somewhere. So if we can talk in that space, which is what are those things we measure, and can we develop that database that clarifies how these different metrics correlate with what we care about, then it's, I think, a more powerful conversation.
Yeah, and I guess I would add to that we're obviously talking about the older metrics of we've looked forever at the fertility aspects of soils, availability of plant nutrients. We've looked at the physical properties of soils for a long time, especially related to holding soil in place and making sure it doesn't blow away or wash down the hill. But the microbiology and the microbiome, that's what's really coming to light now and offers some real promise for better understanding of a lot of those process-driven functions in soils. So to me as a soil scientist, it's just soil science. It's comprehensive soil science. Bringing everything to bear, the chemical, physical, and biological, all integrated together and interacting with one another. So that's how I think about it. And so I was telling Linda a little bit before this opening that as president of the Soil Science Society, I was suggesting to our board, well, maybe we're doing a lot to shift our publications to Wiley and trying to up our impact factors of our journals and so on and so forth. So maybe we need a new journal to capture this latest trend in soil health interest and research. And there is no soil health journal. So that's what I suggested. I said, well, you look at the past trends, and I actually did a Google search of terminology of fertility. That's been increasing since the late 1800s and still continues to increase, but it's leveling off. And then there was soil conservation that started probably mainly with the Dust Bowl and creation of NRCS or SCS back then. And now that the citations with soil conservation in the name or keyword have kind of leveled off. And soil quality started in the early or late 80s or 90s and has continued to rise. And then more recently, soil health. So you can really track all of these trends in soil science. But, I'm speculating that soil health is not going to go away for a while. And it's going to continue to rise and be a very popular topic.
So do you think that shift reflects changes in the way that people are doing science, or just a shift in terminology?
I think it might at least reflect a more holistic view of soils, not just focusing on chemistry or the fertility or the physical structure, but trying to see how everything is woven together and integrated. That's kind of my sense.
I think a big change is that what we can measure from a microbiological perspective has changed dramatically in the last decade. And the fact that we can now index the entire community, not just that tiny fraction that we can culture, and the fact that we can look for functional gene and their abundances, I think that's really critical. I think, we're not very good at it yet, but being able to look at gene expression, the transcriptomic, proteomic, and metabolomic spaces, those are going to be achievable in a high throughput way for soils. And I think those things will be game changers. And that's really driving a lot of the discussion too.
Yeah, that obviously is that's the kind of the cutting edge of soil health in the research world. And then we have to ask the question: well, what when you get to the more applied end, what actually can be measured at a commercial level to inform soil and crop advisors or producers as to how they can adjust their soil health metrics. It's going to be very complex because I always think about the analogy of humans and think about the health. If you want to describe the health of yourself, one of the major metrics is, well, you take a blood test and you have a number of different parameters of your blood that will indicate whether certain functions are happening well or not. And I've been through all that a million times over the last 10 years. But what's interesting is that there's a very common range then that they apply to almost all humans. They might shift it up or down for your age or your ethnicity a bit, but it's a very common range that they want to see a specific metric, whether it's red blood cell count or white blood cell count or whatever, enzyme or whatever. It's all the same for all humans, basically. But the big distinction with soils is that each soil series or type is going to have a very markedly different range of normality, I guess, or low, normal, and high. So that'll be the challenge for us. Even within our state, which has very diverse soils, we'll probably need to develop, okay, what are those ranges of low, normal, and high for whatever metric we're trying to look at.
Well, thinking about precision ag, one of the things that agriculture, in terms of what people are ready to sell, is way out in front of, I think, where the science is. If you look at some of the trace genomics and some of these companies, I think the promise is there, and I think, I can't speak for this room, but many people I work with believe that the potential to do finer scale, even precision management of soil metrics, soil microbiomes, it's out there. We're not there yet. I think NSF, I don't know, the Signals in the Soil program that NSF put a lot of money in, that's a beautiful, well-funded program that's trying to stimulate people to go towards that. What is it that we can measure in real time that's going to be actionable for growers? How do we push that science? But the back end of that is, well, wait a minute, what do we really know, right? We can envision these amazing things we can do, but that foundational information, we're still filling in. So I think of this soil health, we've got, Washington is one of the partners in this 10-state potato soil health project going from Washington and Oregon to Maine. And what we're really just going to do is try to get really good metrics of everything we can think of to measure in the soil and the microbiome in the potatoes for 4 years across 10 states, right? I mean, we still just need to do that before we can really get out here where I mean, I personally believe the potential is amazing, but it's, you know, what the known unknowns and the unknown unknowns, I mean, we're still back there. But the investments are going to drive it forward.
So this is actually the first I've heard of this 10-state potato project. And there's all these networking projects going on. You know, we're involved, I and Isaac and Catherine are involved, and Tara are involved with this NRCS project that's, I think, got 8 institutions now looking at specific soil series and the metrics of the 17 or 18 different measurements across that soil series. So it rapidly becomes a big data challenge, right? And so, you know, how do we coordinate all that data and make sense out of it and piece it together?
I was hoping that the National Soil Health Initiative, the Noble Foundation, would help drive some of that, although not to disparage, I wish that microbiome piece of that would get a little bit more out front. That would be helpful, but coordinating these efforts, there's a new program from NSF, ExcelNet, that specifically exists to network these multiple projects where there's power, and they're giving grants are $2 million to try to put infrastructure of research teams together. Just an aside, if that were something.
Yeah, I mean, there's so many of these networks that, you know, Dave is leading a local LTAR, which, how many sites are there, Dave? 8. And they're all gathering soil health information?
Yeah,
more or less.
to certain extents or another.
Varying levels.
It's not extremely well coordinated, right?
Yeah.
There's some intent there for sure.
Yeah. And then within our state, I guess the proposal is to have a number of LTAR type sites located in different soil series and major production systems across the state. And WSDA will fund the work that's going to be done on specialty crops, a number of specialty crops in western and central Washington for the most part. And Deirdre Griffin is going to be coordinating that, I think. Is that right, Rich?
Yeah, together with WSDA on the initial, trying to get a sense of the initial map. There's a lot of interest in mapping soil health, baselining soil health. You know, what that means, how we do it, I think is yet to be, you know, across the diversity of soils, ag systems, climates in Washington State.
Yeah, so those of us that have been in soil fertility know the game of, well, what are you measuring? When's the best time of the season to take a sample? You know, what kind of spatial considerations are there in sampling, both respect to across the landscape or with depth? You know, there's real questions about what is your soil health with depth that maybe hasn't been a big focus, but we're trying to really emphasize that, and the NRCS project is emphasizing that. Whereas you look at what's happening with the Soil Health Institute, they've commissioned soil health measurements over 100 something sites in North America. Just an incredible effort. And we've got 3 sites here in Washington that they recently sampled this past year. But they're only going to, what was the depth?
6 inches.
6 inches, yeah. So, I wanted to see more depth and maybe less sites, but they decided to spread it out and go with the surface horizon.
They're kind of assuming that everybody's a human.
That everybody,
There's only one soil type.
yeah.
Yeah, so are there any other new tools or technologies on the horizon that you're excited about?
Well, as it goes on, I guess, and I'll let you talk about the microbiology, but in terms of as we put more emphasis on these things from the physical and chemical side, like all of a sudden there sprung up a new tool for measuring water infiltration from the meter group. So these things are all evolving as people show more interest in it.
I think there's some really cool ideas in the microbial space. Some of them have to do, how do you map microbes? With precision ag, you might have your field all computerized, right? But what's a real-time metric of microbes? And there's ideas of some microbes with little circuits placed in them that can detect particular volatiles that indicate early stages of plant disease before they're visible, below-ground plant disease, that can detect microbial populations, antibiotic production, other functional capacities, P solubilization. If these circuits could themselves induce volatiles that could be detected at very low levels as a recorder moves across the field with a tractor. Some of these ideas, question whether there's volatiles that could be used in that way. Some of these magnetobacteria, could you have detection of very small changes in the magnetic field, right? And partly you're like, oh, that's crazy. But partly it's actually kind of creative. Like, could this be accomplished in ways that allow you to develop real-time sensing of microbial functional capacities in soil? What if they're detecting particular virulence gene chemicals? And so I think in the microbiome space that the signals in the soil projects that were submitted had some really, really super creative, where do you go from creative to wacky? But I think that there were people right up against that edge, and I think sometimes that's where you do get the really transformational outcomes. So I think there's some creative stuff going on right now. How much of it pans out? I think it's an exciting time.
I like the idea of a soil breathalyzer test.
Yes, isn't that a great idea? A breathalyzer sells better than volatiles, yeah.
What about remote sensing? Neither of you really mentioned remote sensing. It seems like there's some inherent challenges in relating, satellite.
Define
type data.
remote, right? Do you mean, because realistically, a volatile sensor across the ground for things underground is remote. Do you mean like?
I guess I was thinking, there's been a lot of interest in satellite imagery for mapping forest function and that type of thing. But yeah, it seems like there's inherent challenges with looking underground.
Yeah.
For those kinds of data.
But with drones, drones I think are game changers in a lot of ways too, because a drone can collect data at a finer scale than say Landsat. It'd still be fairly economical. They can generate a lot of data. With low energy costs.
And you had mentioned earlier the big function of carbon sequestration and measuring changes in soil organic matter, and that, remote sensing of organic matter, that's been investigated since the 90s and continues to evolve with more sophisticated imaging.
So what do you think that we're not paying enough attention to in terms of soil health?
You're asking me first?
Yeah.
Well, I have to give it up to the microbiology at this point. There needs to be a lot more work on that, and because it's such a diversity of living organisms that we don't really know much about yet. So, and the balance between, I always think, simplified terms of crop production, the balance between beneficial organisms versus parasitic or pathogenic organisms is really where you're going to be able to make your money, at least with respect to producing crops.
I'm not sure what we're not asking enough about. In some ways, I mean, you mentioned all these, I don't want to say uncoordinated efforts, but there's lots of efforts that might not be coordinated as well as they could be. I think one thing that much as it can be frustrating to look at federal funding, I think the federal agencies have actually been really responsive to this space in the Ag Microbiomes new program they put out, in this Signals in the Soil program, which is it involves, you had to have an engineering component and a biological component. I think the federal government is actually really receptive to this space. So to some extent, I think the question you asked is one that we in the scientific community should be attempting to articulate answers to the federal government. Because I think that the promise is there. The growers that I talk to are super excited about soil health. They can't define it. They're super excited about microbiomes. They don't know what they need. I think that the energy is there, but what the needs are, we probably haven't sat down and talked about that question enough, because maybe one of the things we really do need is the federal government to say, holy cow, if you add it all up, you're investing $112 million in soil health, and everybody's their own shop, and that's not good enough, right? Maybe what we're not asking enough is how can we make the whole way better than the sum of individual pieces. I mean, it'd be more fun to say there's this really cool science space we're missing, but I think there's a discussion that might go with it. And I do think the lack of coordination is going to limit the value of lots and lots of millions of dollars of state and federal and commodity money. I don't know. I want to know what a graduate student thinks.
Well, I think one big thing we're not looking at is nematodes. A huge part of the soil ecosystem at all trophic levels, and you very rarely see anything, and they're kind of behind in developing the tools, and there aren't that many nematodes. I mean, they're an extinct breed. And then the other thing I would say is protozoa. Proteins, another huge.
And viruses.
Saying that.
There's viruses right behind me. Yeah.
No, there's taxa for sure that are just like big voids. Yeah, great point.
So I guess I have a question, I'll follow up on your omics question. So say you're able to measure something in the field with high precision, something like an Anapore device, direct RNA. Is it better, what would a better measurement be? Would it be temporal? Would it be spatial? Would it be both? Like what would be the types of, would it be down a soil column? What would type to measure, let's say, gene expression better to be more correlative to soil health?
So are you saying like when or how should we sample, or what or when should we measure?
What types of data would be more critical? Down a column, spatially, or over time?
I don't know the answer to that question, and to some great extent, I think a lot of what we're doing right now is mostly going to inform how we should be doing it better in the future. I mean, I think a lot of these data sets, the northern tier potato production, we tried to put our best guess on when we should sample, how deep we should sample, and what we should sample, and we might be completely wrong. And maybe a good question might be, how will we know if we were right or wrong, right?
I guess that's
And so, to some extent, it might be correspondence among these, or comparison among these studies that might help refine the approaches we should be taking relative to what we think is right.
So in those studies, were you defining what functions of interest you had? Were there strong linkages between what you were measuring and the functions and processes of interest?
Our project was specifically focused on diseases. And so yes, we're really looking at pathogens and pathogen suppressive capacities as sort of one of the key issues. But then just in terms of budget, amplicon sequencing is relatively cheap. Is it perfect? No. I mean, the more some of these other techniques develop, the greater we see the limitations of amplicon sequencing. But
So-
partly it's just how do we start?
How does that link to soil health then? Because you're describing a whole different set of objectives in terms of looking at disease.
Well, we're also looking at soil chemistry, we're looking at soil, physical
But what
characteristics.
functions then are those trying to capture
You know-
standpoint processes of interest?
Our main, okay, even though I say disease, we're measuring disease and we're measuring yield, productivity. And so then it's largely a national correlative study, what do microbiomes look like? And we sample pre-plant, and we sample mid-season about the time of tuber initiation, about 60 days post-planting. And we are just asking what factors, if any, can we see that are consistently correlated with yield or with disease? And it's an experimental structure. There's 12 different treatments in every state. 4 of the treatments are the same in every state. Then the other 8 treatments vary with every state based on what their local grower populations were most interested, what kind of production schemes were they reliant on in terms of rotation, green manures, and so on. So it's far from perfect. We chose an arbitrary depth that most of us felt comfortable about. We fought tooth and nail. Is it 6 inches? Is it 3 feet? Is it somewhere in between? And it was a series of grand compromises among about 28. I think there's 28 people ultimately on the project.
And what did you settle on?
I don't actually want to say off the top of my head because I could get it wrong. I think we went 15 centimeters,
Okay.
which is, I mean, you could say 15 centimeters for potatoes. Is that deep enough?
Guess you'll never know.
But that's my understanding. The soil science folks, that's what they do. They use 15 centimeters, right?
For routine soil tests.
That's
And
what we were
that'll-
told. So we said we were told that if we want to fit in with the soil science world,
Yeah.
we needed to go 15 centimeters.
Well,
And at the end of the day,
you shouldn't follow that because that,
it's too late.
it's an erroneous assumption that was,
Although we
came
have.
out of the Midwest and South regions where continual precipitation, most of it stayed up and up.
So the other thing we in our project, we are open to amending our methods. It's a 4-year project. If there's a better way, we don't have to stick with the bad way, right?
Yeah, I just think with, if you're looking at crops, you should consider the whole rooting depth, which is what we do in soil fertility with some of the nutrients, but not all of them. Now we're starting to look at all the nutrients. But I guess from a more, a higher viewpoint, I always go back to Inslee's first question when he kind of launched this whole thing after reading Dirt. And he said, well, and he said this to the directors of all the state agencies. He says, what's the status of our soils and our topsoil in the state? He was really focused on topsoil, which was featured in the book. And because his understanding then was, so you started eroding the topsoil, you started eroding the productivity and the functionality of the soil. And certainly that's true in a lot of the ag production systems. Maybe not so much in irrigated potatoes where you start out with pretty poor ground and low organic matter, and so just having enough rooting depth is the main thing. But so thinking about that question then, and I think we kind of, WSU and everybody kind of pivoted that question into the soil health arena, but his original question was really topsoil depth. And which we think about a lot in soil sciences. Okay, we've degraded our soils as measured by loss in topsoil depth over the years, over the last 100, 120, 130 years. Basic question in soil health then would be how to restore that. Can we actually rebuild the soils and the soil topsoil? So that gets into management practices that would be required to, really ramp up the organic nitrogen, carbon pools in soils and see how much you can really raise organic matter. And so you turn to long-term experiments and you see, well, it's mostly done with manure in these long-term experiments. that can at least maintain the organic matter or with continued tillage or even increase it over time. There's really good evidence in these long-term experiments for doing that. So that would be one thing that I think we, in a soil health initiative, we want to make sure that treatments across these long-term experiments that are established or adjusted now with the soil health initiative, make sure that we have some treatments like that, and then figure out ways to actually deliver those organic amendments where they're needed, which is really the big challenge, where especially where we've separated our cropping from our animal production systems spatially. So we concentrated feedlots, moved away from crop production areas. So getting that manure back to the land is more difficult. So I think that's one of the major challenges.
It's not just manure though, it's carbon inputs in general.
Right, any carbon inputs.
And eliminating fallow is another kind of strategy, and there's other strategies with respect to what we actually grow, annuals versus perennials, et cetera, that follow that path in terms of carbon input changes.
Right, yeah, so cropping systems, manure, biosolids, urban compost, wherever you can get it from, cover crops.
But I think one challenge we have, though, is I mean, even in this discussion, we can't answer all the questions like the first step out. And I think that the microbiome emphasis, sure, I want to understand what drives it all, but first I just want to know sort of what's there at a much larger scale of space and time than we have in a systematic way. And the good thing is, the organic matter, the carbon, we have organic amendments. In the national project, it's mostly green manures and covers. It's not animal waste. It's not bringing in biochar or some other input. But just finding out what's there is going to be a really important first step.
When you're doing it, are you just looking at like doing metabar coding, or are you guys looking at metagenomics?
We're not doing metagenomics right now. We do have a potential partnership with Beijing Genomics Institute, but right now that's becoming less of a great resource for us. We were going to get some really low-cost metagenomics in addition to the amplicon sequencing, which we're doing here in the U.S. And so.
I have an idea.
Okay.
Is there thinking along these lines to be more diagnostic in terms of soil health, rather than having, here's the 31 different things that everybody measures, or here's the common depth everybody measures, rather having a strategy where you go into every situation, which tends to be unique, and actually have a strategy to go forward with. These are the kinds of diagnostic tests that I would like to pursue from the standpoint of functions of interest in order to actually develop and metrics and measurements that are going to be useful from a decision-making standpoint in terms of what growers or producers or whatever you're trying to manage for across our various ecosystem services. So from that standpoint, I take much more of a diagnostic approach to this, which tends to respect the uniqueness of each situation, rather than these kind of shotgun blasts across the country that really may start a good conversation on soil health, but might also end it from the standpoint of farmers. This is exactly what happened back in the 80s and 90s with the soil quality. We had the minimum data set. We had 0 to 20 centimeters that we all measured. What happened to that? Well, it fell flat in its face from the standpoint of being actually useful, from the standpoint of people that wanted to use that concept. And so how do we not make that mistake again from the standpoint of what I'm seeing actually in terms of many approaches to soil health right now that might end the conversation rather than providing really useful diagnostic metrics that farmers and other land managers might use to improve the functionality that they can improve through their various management practices.
Yeah, I agree with that. And I think it is a mistake if people are already going out and saying to growers, okay, make these 18 measurements on your soil, we'll try to figure it out. That isn't the way to go. So prescribing a certain set of metrics that are most critical for given ecosystem is going to be critical. I think the shotgun blast is really just starting the research out and trying to figure out, well, which ones are the most important for different scenarios. It's, you know, going back to my analogy of the blood tests, it's like, okay, well, you got psoriasis, make sure you get this diagnosis, or this series of tests, or you got cancer, well, make sure you get this set of tests. So I think that's what you're talking about.
Well, I think that what you're talking about too is a really different kind of science that needs to be done. I mean, right now, we still don't really even know what's out there. We don't really know the spatial scales at which these microbiomes vary in potatoes within a field, which we have in our design, across fields on the same site, across different farmer fields within a state. And I think until we begin to even have some quantification of what that variability looks like, we can't even begin to consider what it is we should be measuring, where's the diagnostics. And so microbiome science is in an early enough phase that, I mean, it's to some extent it's natural history, but it's where I think the science needs to start. I can do a great job in my own field, but if it's completely different from a field 2 miles down the road, it makes no difference. And so I think those scales of variability are a really important sort of baseline.
So given that variability is out there, and it will be.
Pardon? Oh, it will be.
And
but
so how do you even approach the science in a different way, perhaps, that will actually link the function to these kinds of measurements more strongly, so that you can actually discover how that linkage, how strong that linkage actually is. And I'm not sure our approaches in the shotgun really do that justice from the standpoint of actually linking the kinds of measurements we have to the functional kinds of expectations and processes of interest.
So you've talked about carbon being really important, right? And so how do microbiomes vary with carbon within a field versus over much larger spatial scales versus with soil type? I mean, microbiome, we don't actually have that kind of information. If you can already tell me that carbon is something that you believe is a core metric for soil health or productivity, then we need to look at what the microbiome story is in relation to, for instance, carbon quantity or label of carbon or carbon profile. That would be a really, really important first step. Is the carbon story actually a lot of microbe story, or are microbiomes completely delinked from the carbon? So it actually is just a carbon story, right? And so some of those things we have to just start by providing a database for these general queries, because we don't know. Well, and I mean, I think we should be concerned. You do have companies out there that are basically selling, I can look at your microbe and tell you, or your microbiome, and tell you what you need to do. And I see no evidence that that can be done. But right, that's where we at the land grants have to step in, right? If we don't believe that, then how do we build a bridge to get there? And partly it's a huge paucity of data.
Yeah, I just had sort of a thought to add to this idea that actually brings us back to that very first question about what is soil health. And you bring up a great question about, we've gone through these ideas of soil quality and fertility, and although I wasn't necessarily a part of the movement of soil quality, and I'm not exactly sure what you mean that it failed per se. Because I guess when I was coming about in terms of learning and understanding what these ideas of soil quality versus soil health, what those fundamentally meant, and then now teaching it to students, for me, soil health is about a living, breathing entity. And it's not just about growers, although agriculture and agroecosystems are a huge part of the planet, obviously. But for me, the idea, the movement, the understanding of soil health has a lot more to do with, obviously I'm a microbiologist, so it's the soil biology. It's how soils live and breathe and keep the planet functioning. And so for me, I don't think we can fail if we fundamentally raise awareness, for one, as a small part of what we do, right? That soils are fundamental in everything we do every day. Not just the food that we eat every single day, but the air that we breathe and the water that we drink are all products of ecosystem services that wouldn't happen without soils and the biology that occur within the soils. I've been a proponent and simply devil's advocate of biodiversity simply for the sake of biodiversity, but if we're gonna get really into how soils function, which is really what we do come back to with the definition of soil health, is like soils need to continue to function the way that we expect them to function. They need to do the things that we want them to do, more or less in perpetuity. And that has to do with what is it that we need the soils to do? Well, basically everything, right? And I'm right there with you on, there's a whole lot of basic science that we don't understand about the microbiome. We may have measured soil carbon all day long for 100 years, but we certainly don't understand how the microbiome is controlling that on a very level. And then in turn, what to measure in order to say that the soil is healthy or not. Of course, we need to incorporate individual growers' needs when we're looking strictly from the agroecosystem and, what do growers want to know about their soil health and how to enhance soil health.
Elliot, could you mute your mic?
But a lot of what I feel like I hear is coming back to this idea of uncoordinated efforts, especially on a national, but even international basis, because everybody's coming at this from a different direction. And as president of the Soil Science Society, I wonder, you mentioned something like a journal, but I'm curious on even a bigger level, those of us in this room and those that are involved in the Washington State Soil Health Initiative, how do we work harder and start to make a voice for trying to coordinate national efforts besides sort of that funding mechanism of trying to provide a space for soil health, but even just bringing together some of these uncoordinated efforts and saying, let's all sit in a room on a much bigger scale and really not only raise awareness, talk about what these metrics are, don't just throw 30 metrics at it and say we're done, but really analyze some of these larger global issues.
It's much bigger than a society, obviously. I mean, you look at the whole space of soil health, and there's so many entities that are involved with it now. Soil Health Institute, NRCS, Nature Conservancy, Ecosystems Services Marketing Consortium, goes on and on. And then on the international level, FAO and a host of others. So yeah, how do you coordinate all of those different efforts when they've already gone off in different tracks? It's going to be a real challenge. Richard Dick, our former president at Ohio State, has suggested that maybe we at least coordinate a European, U.S. or North America conference on soil health. Try to get more coordinated. But even that doesn't capture it all. There's more countries than just Europeans and U.S. that are working on this stuff.
Yeah. Bill mentioned the Soil Health Institute, and before that it was the Soil Renaissance, right? So there was a national effort, basically, meeting in Ardmore from soil scientists around the country to talk about soil health for 3 or 4 years. So the intent was to try to look at just what you're describing in terms of, okay, what are the current metrics that we're using, what are the laboratory methodologies, how standardized are those, et cetera, et cetera, et cetera. So big discussions on all those issues that brought forward. And what you see right now in terms of their first effort is this assessment, national assessment of soil health. At this point, those 31 metrics, we went through a survey process to determine, well, what were the metrics of interest, and basically and everybody contributed to that, and that's how they came up with the 31 most popular ones. But every one of those were rated from 1 to 10, and every one of them rated from 1 to 10 in terms of being unimportant to extremely important, which just kind of defines the very issue that we're trying to grapple with here in terms of coming up with, universal metrics that somehow, translate into something that's useful from the standpoint of the functions of interest. And so I guess, from a land management perspective, it's going to be really important, I think, to try to make that, try to strengthen. And that can start to involve, more process-oriented modeling. And so what's the process-oriented model that now integrates the soil microbiome into it to describe some of these functions? Is there one out there? I don't know if there is even. So where do we start to take all this data that we're collecting and link it to a functional model that tries to look at the mechanisms involved, and what does that look like even as a model, and how does that integrate with the models we already have, carbon and everything else?
Well, there's going to be a fundamental challenge. It's not unachievable, but the soil models are a lot chemistry models, right? And
physics or chemistry. Yeah.
Right.
There's some biology there too, but it's
the biological models
secondary.
for community.
It's indirect biology, agri stability. Right.
But the models for community function in organisms, communities in which you might have 10 to the 8th organisms in a gram of soil, candidly, we're not there yet, right? I mean, I think, synthetic communities are helping drive some simple community models, but scaling them up to the complexity of a soil microbiome, I think that we're still a long way from there. But the other question is, the question of redundancy in soil microbiomes is a really big one. How complicated do we have to be to catch? There might be 10 of the 8th organisms there, but maybe there's 14 that matter, right? I mean, we don't know that yet. So I think you're asking really great questions, but I think they're beyond our horizon right now. And we still have some really good ways we can move the ball forward, even though we can't do what you're suggesting yet. Some of you.
Yeah, I was just going to say that. Is it really, Jim Prosser said this in Braunschweig, is it, are we measuring the color of cars and trying to figure out, how the, amount of CO2 coming out of the car?
Right.
Is it the, are we measuring the wrong thing, basically?
Right.
And is it the functions that we should be measuring and not the actual species, if you will, because there is so much functional redundancy. So, is it better for us to go at a kind of a non-functional gene approach to tackle some of these issues? It's a question.
Well,
it's the who or the what they're doing.
Well, and if we had, another huge data limitation, we can do metagenomics. We can get thousands of gene sequences. We have no idea what those genes function or what the function of those genes is like, because the gap between the sequence and the functional databases for microbes in soil is still enormous. I mean, we all are super excited about it, but there's still this huge chasm. But we still have to start collecting information, right?
It's a combination of CETOs and microbia that are just non-culturable, hard to work with. Their genomes, when you do pull them out, they look like everything else. So what are they doing?
Not to mention the protease and the viruses and the nematodes that,
So if I could get you guys to just maybe peek over the horizon, do you think that we'll ever be able to create soil on Mars?
Yes, because that was a Star Trek episode. So I believe we can.
Well, define soil.
Yeah.
Right? I mean, I could buy soil in a bag, soil mix and synthetic soils, right? So
We could just ship it to Mars, grow food that way.
it'd be nice if you could ship the microbial packet to go with it. Yes, I'll give it a yes.
Any other closing questions? All right, thanks.
These are like the seats from, remember the dating game? Dun, 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 dun. Yeah, that's right. That's terrible. Where did you find those? Yes.
I got them on Amazon. I bought these.
Seriously?
Yeah. I bought these standing desks for my lab.
Yeah.
So I wanted, so I wanted to get like science to go with them. But no one actually. Oh yeah, so Mike.
Right.
Yeah, no, it's
Now I'm calling.
Yeah, that's just your problem. Says, are we measuring, you know?
Brett and Rick are over there, but I'm not.
Pleasure. A little later, run really quick.
Okay.
But I didn't want to leave.
All right.
But I look forward to seeing you.
All right, sounds good.
Sorry. Yeah, could you please? Thank you.
I was actually. Well, yeah, you know.
Trying to grapple with other things.
But I think there's the other part. We just post metadata standards.
I would lean towards the science part.
No good though, but for you, other people,
Oh, no, the growers are into it, yeah. No, there's a sweet spot here, but it's not next year. I'm gonna I don't know.
Okay, that's fine. They can just pick. We're getting after them.
No, there's
No coffee. How are you?
Oh my God. No. You guys have some problem. What's going
Dave, it's not working.
Yeah, so can it be jammed up or? Oh, man. Coffee time. Turn off.
Well, and that's only like.
But she's famous, we can sell this signature.
Yeah.